Hey, this is Mr. Bells here. This is going to be a quick video kind of going through some of the geometric constructions. I'm doing my best to be able to get you angle views for it, to be able to see it. But one of the things you're going to want to have is a nice compass right here to be able to do it. And then, of course, another thing you're going to want to have is a straight edge. So here's some quick snippets of videos for being able to do constructions and what we need for it as we go. So basic straight edge, something like that's fine. The first one we're going to talk about is a segment bisector. And what we're looking for specifically when we do this, we're going to call this a perpendicular bisector, which means we're looking for something that is going to end up being at like 90 degrees to this thing, but also splitting it into two equal parts. So that's what the goal is that it's going to look like when we're done. But we can't just draw it freehand. We want to be able to get the exact points on it. So we're going to take our handy dandy compass right here. We need to open it up more than half the distance of the segment. So as long as it's there, as long as it's more than half, it doesn't matter how far it is more than half. And we're going to take it and we're going to put the metal point right here on one of the arcs like this, and then bring it down below and kind of spin it like that. And do it long enough so that it goes at least above and below wherever we think the approximate middle would be. You're going to do the same thing on the other side. Put the metal point again at the end point of the segment, and you're going to cross the arc up at the top and cross the arc down at the bottom so that there's an arc crossing in both of those two places. Make sure that during that time period your compass has not changed opening size. So if yours slips around a lot, really try and hold it tight so that it doesn't slip. Now that I have that, these 2 points right here where that arc crosses and that arc crosses are the 2 dots that we're going to connect. We know that geometrically speaking, there's one and only one line that exists that goes through those 2 points. That's the one that I'm going to do. And what I've just created is something that is exactly 90 degrees or perpendicular to it. But I've also done that if I have a point A, point B at that intersection, and a point C out here, I've made it so that segment AB and segment BC are congruent. So AB is congruent to BC. And again, that's a perpendicular bisector of a segment. And I don't know if you're using this video for the one for the circumcenter of a triangle, which is something we'll talk about in class. But that's what you need to do on all 3 sides of a triangle to be able to find that circumcenter. So perpendicular bisector, again, that's the review for that. Next one that we're going to do, we're going to do an angle bisector. So of course, the first thing I need is an angle. It doesn't matter what angle I have. I'm just going to go ahead and put a random angle on this thing. I need to connect it from the end point of the segment out. So I've got this angle right here and draw the rays on there. So the first thing I'm going to do if I want to bisect this angle is I want to have some common sense beforehand. So like if I drew this thing out and I said, hey, people at home watching the video, does that look like it's angle bisector? Hopefully your answer is no, no way, shape or form, because this angle 1 in here and this angle 2 here, those are 2 completely different size angles. So if we're going to bisect this angle, we want to make sure that we get something that goes directly and splits the angle into 2 equal parts. Now, of course, it has to go through this vertex over here. So we're looking at something that might be about like that, maybe. Okay? That should split that into 2 equal angles. So the angle here and the angle up here are identical. And this is what we simply do. We take our compass. We got it open a certain amount. It doesn't matter how long it is. Just make it go a little bit further. Take the metal part and stick it right there on the vertex and swing an arc so that it goes through both rays. Then keeping that the same or changing it, doesn't matter, as long as when I swing these next arcs, and I'm going to swing the arc from, we'll call this vertex A. I'm going to swing the arc from the 2 intersection points B and C into the middle over here, so they're going to touch someplace in this area. So again, metal part on B, take that, swing that through the middle. Metal part on C, take that right there, swing that through the middle. And now this point right here where those two intersect is called D. Now I'm simply going to connect A to D, and that point, those 2 points that I'm connecting should give me an angle bisector. And what does that mean? That means that this angle right here and this angle right here should be congruent. And again, I would write that out as angle CAD is congruent to angle DAB. Again, C to A to D, D to A to B, those two angles are the same size. So again, perpendicular bisector, and this one down here, angle bisector. And both of these, again, if this is the only video that you're looking for, that's great. That's exactly how you do a perpendicular bisector. That's exactly how you do an angle bisector. If you haven't seen this next thing, that's okay. You don't have to worry about it. And I'm just going to freehand some sketchy stuff in here. If I was to do angle bisectors on all of these ones and went through the formal construction, I'm not going to do that right now, but if I went through the formal construction, and I get that would be about an angle bisector there, and this would be about an angle bisector there, and then this would be about an angle bisector there. All of those points are going to intersect in that one location. And then if that's the exact center point, and this one's off by maybe just a smidge, maybe it should be about right in there, there should be a circle that fits perfectly inside that triangle from that point being the center point, if those are all angle bisectors. And you can see that I had a little, this one should have gone a little bit lower as it went through. This one should have been a little bit further over as it went through. That center point right there to any one of the edges, perpendicular, that should give you that triangle. Again, that point inside there is called a circumcenter, or an incenter, and this circle is inscribed inside the triangle, an inscribed circle. There also, if I had one like this and I did perpendicular bisectors of the sides, so I bisect that one, and I bisect that one, I bisect that one. All three of those bisectors, perpendicular bisectors, means they go through the midpoints, right, of the sides. Those all intersect. And then if I took from here and reached it out to this vertex, or this vertex, those distances would all be the same. Again, if it was, they were done further. If that's what you're looking for in the videos, again, the angle bisectors from this and the perpendicular bisectors from this, we would do formally here and here. I just don't want this video to be a 30-minute video. Hopefully that's really helpful for you, and that you're able to knock those out accurately on your worksheet for this. Awesome. So again, this is Mr. Bell's quick review on some angle constructions using your compass and straight edge. Talk to you later.